Hello, welcome to the video on function operations. This will be a lesson on this topic. And this isn't too difficult if you understand how to deal with polynomial operations. So it's going to be very similar to that. So let's go into our objectives. Basically, we have one. We want to be able to perform operations with functions. And let's take a look at what that means. Okay, it really isn't too difficult, these function operations. It's actually pretty easy if you understand dealing with operations with polynomials. I think that's a very good analogy to make here, and it's almost exactly the same. One thing I want to make clear though from the beginning is that although these particular functions that we're dealing with here happen to be polynomials, functions don't have to only be polynomials. You can have all sorts of functions. So the concepts that we're going to learn in this lesson apply across the range of all kinds of different possible functions you could have. All right. Before we get going any further here, just want to make sure you understand what we're talking about. Function operations. What do you think this means? Okay. Well, obviously we're going to be dealing with functions. Okay, like as here we have two functions, f of x and g of x, but we're going to be dealing with operations. Okay, and if you remember the order of operations, okay, mathematical operations are addition, subtraction, multiplication, division, powers, and a few other things. Okay, so we're going to be doing these mathematical operations, the ones I just listed here, involving functions, not numbers. Okay, so with that said, let's go ahead and take a look at f of x plus g of x. f of x plus g of x. Okay, so this is your function g of x, and you have the function f of x. What do you think this means? Curious. And just take maybe a moment here, and logically, what do you think it means to take f of x and add it to g of x? All right, so some of you might say, well, f of x is the same or equal to 3x plus 2. And I'm going to take that function and I'm going to add it to the function g of x, which is negative 4x minus 1. Maybe that's what it means. Okay, so if you guessed what I just wrote here, then you would be correct. It's very logical. Okay, so these function operations aren't difficult, and I think they're actually rather easy. There are some pitfalls, and we're going to talk about them in a lesson, but that's all basically we're going to be doing here, is combining two functions, just as I did here, in some manner, and simplifying them. Well, one thing I do want to bring to your attention is, oftentimes when we perform a function operation, whether we add two functions, or subtract two functions, or multiply or divide, we often call the result another function name. So in this case, for example, maybe I want to call the result of adding to these two functions a new function called h of x. All right, so you might see that also in some problems. I just want to make sure you're aware of that. But let's go ahead and actually do some examples now. So this is our first problem. F of x and g of x are defined, and I want you to go ahead and add them. So take a moment and set this up. All right, so we have f of x, which is 3x plus 2. Okay, so this is the function f of x. I'm going to add it to g of x. So you're going to want to write that function f of x there, and we're going to add it to the function g of x. Okay, and g of x is equal to negative 4x minus 1. So you're going to want to write that there. Okay, now once you substituted in the value of these functions, you want to simplify. Let's take a look what this is going to look like. So this is going to be 3x plus 2 plus negative 4x minus 1. Now when I simplify, these are skills that you should already have. What I mean is combine like terms. Okay, so we have 3x and negative 4x. We can combine those. It's a negative 1x, and we have 2 and negative 1, and I can simplify that as a positive 1, and there you have it. Okay, so f of x plus g of x would be equal to negative 1x plus 1. Okay, and of course I could say, well, I'm just going to call that a new function h of x, which is equal to the sum of those two functions, if I chose. If not, it's perfectly fine just to write it like that. All right, so now that you have a pretty good feel, hopefully, for what we're doing here, why don't you take a moment and see if you can do this problem, okay? The difference of f of x and g of x, all right? You're going to subtract one function from another, so go ahead and set it up. All right, so here we have the f of x function, that's 3 of x. We're going to write that there. And then we're going to subtract the g of x function, okay? We're going to write that there. Now this is where students make errors, and let's see if you make this error, because if you make it and you understand why you made it, then hopefully you'll know not to make it in the future. All right, so let's see if you get this right. All right, so let's go ahead and continue. Function f of x is 3x minus the function g of x. Now, if you wrote your problem just like this, this would be incorrect. Okay, what you have to do, and this is the same thing as when you're dealing with polynomials, you have to group what you're going to be subtracting. All right, now why is that? Okay, you must have parentheses. Well, it's because you have to distribute this negative sign, this difference operator, to both terms. Okay, so this is going to be 3x minus 6x minus 4. All right, now we combine like terms. We have negative 3x minus 4. Okay, so that is the correct answer. That's the difference of those two functions. Now let's see what would happen. Back up here. Let's see the mistake that students make. They'll say, okay, f of x is 3x. I'm going to subtract it from g of x, which is 6x plus 4. So what happens is this. They'll get this right, 3x minus 6x, okay, just as they have here, and they'll end up with a negative 3x. But look, they'll have a positive 4, not a negative 4. All right, and this is where the students go wrong. So take note, when you're subtracting one function from another, just as you do with polynomials, you have to group whatever's to the right of that difference operator. All right, moving on. So here we have two functions, and this time we're going to multiply them. If you want to go ahead and set this up, we have f of x times g of x. All right, and that is simply going to be x minus 1 times x plus 3. So you want to go ahead and simplify this, and these are two binomials, so you might want to use a technique maybe like FOIL. All right, and hopefully none of you out there are scratching your heads thinking, well, I don't know what to do next. If you don't really understand how to multiply polynomials, you really need to go back and take a look at that section. But why don't you go ahead and pause the video and see if you can simplify what this is going to turn out to be. I'll use the FOIL method. So this will be x squared. This will be a 3x plus 3x. This will be a negative 1x, and this will be a negative 3. All right, so we'll have x squared plus 2x minus 3. Okay, that's the product of these two functions. All right, so I can write it that way, or maybe I could even just call it a new function h of x. Now, of course, these skills here, this is pretty straightforward, but when we're dealing with function operations, just as in polynomial operations, you're going to have to know some of these skills, combining like terms, multiplying polynomials, etc. Okay, so let's take a look at our last example here. This time we're going to divide two functions. So we have the function f of x, and here it is, 8x plus 10. So you're going to want to write that there, and then we're going to divide it by g of x, and that's 2x plus 4. So we're going to set it up. Why don't you go ahead and set it up? So there'll be the division sign here. And then you want to go ahead and simplify your result. So let's see how far you get here. All right, so f of x is 8x plus 10. G of x is 2x plus 4. Okay, so here's another major pitfall where students often go wrong. Okay, this is 8x plus 10 over 2x plus 4 is what we call a rational function. Now, actually, I'll tell you what, I'm going to go ahead and just hold off 1 second. Go ahead and simplify this result. Okay. Now, if you simplify this result and you did this, maybe I can cross cancel the x's, and this would be 8 plus 10 over 2 plus 4. So maybe this is 18 over 6. That's totally incorrect. maybe he said, well, 2 goes into 8, that's 4, so maybe this would be 4x plus 10 over x plus 4. That's incorrect also. Okay, these are very common mistakes, and you need to go back and take a look at how to simplify rational expressions, all right, which means you have to know how to factor. So let's take a look at the correct way of doing this. I want to erase this. Okay, the way we set up the problem was correct. 8x plus 10 over 2x plus 4. But to simplify a rational expression, you have to factor both the numerator and denominator. Okay, you can only cross-cancel factors. So why don't you go ahead and factor both the numerator and denominator. Okay, this is a skill that you should already know how to do. This would be 2 times 4x plus 5 over 2 times x plus 2. Okay, so that's how the numerator and denominator factor. Now you can cross-cancel these two. Okay, that's allowable because this is multiplication. This is addition. You cannot cross-cancel with a term that's a sum or a difference. You can't cross-cancel between those terms. Okay, you can cross-cancel factors which are have to deal with the multiplication operator, not an addition situation. Okay, got a little tongue-tied there. Sorry there, but I wanted to make sure that you understand that you cannot cross-cancel through addition. You can cross-cancel through multiplication. Those are factors. All right, so we can cross-cancel there, and we end up with 4x plus 5 over x plus 2. Okay, so that is correct. So, common error, students know how to set up the problem. They understand where they want to go, or where they think they want to go, but they get tripped up in some of those core skills. All right, so let's go and wrap this up. In review, okay, function operations are just like polynomial operations. So if you know how to deal with polynomials and polynomial operations, you should be very comfortable doing this. We saw that you need to be very careful when we subtract two functions. And last but not least, you want to make sure you always simplify expressions, okay, where that means combining like terms or factoring. All right. Okay, so hope to see you in the example sets. You definitely want to practice this, and you'll definitely see it again. So good luck and hope to see you there.